Now let us talk about load balancing. Okay, so load balancers are servers that forward traffic to multiple servers. Example, EC2 instances. It means that basically your web servers, you have three particular web servers working, right? This is 1 and this is 2, then this is 3, and each instance has its own public IP, right? IP1, IP2 and IP3. Now instead of communicating with each EC2 instance directly using its IP address, what you do is you keep an elastic load balancer in front of those EC2 instances. So whatever requests are coming from the users, right, these are all the users, that will be forwarded to a particular EC2 instances. For example, you got 9 requests, right? 9 requests. Now what this elastic load balancer will do, it will forward 3 to here, 3 to here and 3 to here. So it will kind of balance those requests. Now it's not going to perfectly divide 3, 3 and 3. It can be 4, 2 and 2, something like that, right? So it can be like that also. Depending on the instances, it will forward the traffic, right? But the thing is, elastic load balancer just distributes the load evenly across your healthy instances. Now why I'm saying healthy, we are going to talk about that later on, but this is the basic concept of load balancing. Okay, now why load balancer? Basically spread across multiple downstream instances, expose a single point of access DNS to your application. As I told you, instead of communicating with each of these EC2 instances using their public IP address, you just communicate with the load balancer, which has a fixed DNS point. Okay, now seamlessly handle failovers of downstream instances. It means that the load balancer will know which instances are healthy and which instances are not, and based on that it will forward the traffic, right? That's what I meant by healthy instances. Now high availability across multiple availability zones, and you can do regular health check of your instances. It means that you can check if your instances is healthy or not, and if a particular instance is healthy, then send the traffic, otherwise don't send the traffic. Simple as that. बहुत ही आसान. Now why do you need to use an elastic load balancer? So an elastic load balancer is a managed load balancer. It means that you don't have to manage any kind of infrastructure, don't have to install any kind of load balancing software or configure it, anything. It will be handled by AWS. AWS takes care of all the upgrades, maintenance, high availability, everything, and it costs less to set up your own load balancer, but it will be a lot more effort on your end. So basically, if you are going to do it as a physical load balancer, you're going to buy a server, you're going to configure it, and it will take a lot of time and it will take a lot of money. So why to bother? Just say tell AWS to handle it, right? It can be integrated with auto scaling groups, ECS, which is elastic container services, which basically can run Docker containers on ECS, right? It can also integrate with EC2. It can also integrate with AWS Certificate Manager, CloudWatch, Route 53, AWS Web Application Firewall, and Global Accelerator. These are all other services. You don't need to worry about that right now, but just understand that elastic load balancer can actually work with a lot of different services. Now let's talk about what are health checks. Now health checks are crucial for load balancers. Okay, they enable the load balancer to know if instances it forwards traffic to are available to reply to requests. It means that it checks if the particular instance is healthy or not. Right, we have this particular elastic load balancer, and there is an EC2 instance, right, which is connected to. It sends a request, and if the EC2 instance replies okay, then the elastic load balancer knows that okay, then this particular instance is healthy. I can easily forward traffic to this particular instance. That's what a health check means. If the particular instance doesn't reply with okay, or it replies that okay, it's a failure, then the load balancer will not reply or send any traffic to that particular EC2 instance. Okay, that is what a healthy and an unhealthy instance really means. Now types of load balancers, if you are going to see, there are 4 kinds of managed load balancers. One is classic load balancer, and this is the old generation load balancer. Okay, and it was founded in 2009. Then we have the application load balancer, which is the newer generation load balancer, and it works on HTTP, HTTPS and WebSocket, which are basically layer 7, that is application layer protocols, right? Then we have network load balancer, which was founded in 2017, developed in, and it works on layer 4, which is basically the transport layer, and TCP, TLS and UDP are all transport layer protocols, right? So it works on the layer 4. Then we have gateway load balancer, which is 2020 mein develop hua tha. It operates at layer 3, which is network layer, and it basically operates with the IP protocol because it is a layer 3 protocol, right? Network layer protocol. Now it is always recommended to use the newer generation. So basically it is recommended to use these three for your application purposes. So basically if you want to do with layer 7, choose the application load balancer. If you are going to work with the transport layer, please choose the network load balancer. But it is not recommended to work with the classic load balancer because it's an older generation. But the classic load balancer supports all the kinds of protocols including layer 7 and layer 3. So let's see all of them one by one. Now we're going to talk about one thing before going to that is known as security groups and load balances. So what you see in this particular diagram, right? When we talked about security groups in EC2s, we saw that we can define inbound rules and outbound rules which particularly control which traffic can flow in and out of your EC2 instance. Similarly, the load balancer also is associated with the security group. As you can see over here, the load balancer security group over here. There are two rules over here. One is HTTP and one is HTTPS. And here is the source. So what does it mean? It says that please allow HTTP traffic from anywhere. It means that anywhere, right? So basically that's what this particular rule means. The second rule means please allow HTTPS traffic from anywhere. Now for some reason, if I delete this particular rule from this particular security group, then what will happen? The load balancer will not receive any HTTP traffic, right? That's how security groups work, right? Now talking about the application security group, which is the security group of this particular EC2 instance. Now what is this particular security group does? It says allow HTTP traffic from this particular security group. Now this particular security group is actually the load balancer security group. It says that only allow HTTP traffic from the load balancer security group. And why do we need that? Basically we are preventing users or the outside world from accessing this EC2 instance directly. Nobody will be able to access this particular EC2 instance directly using its IP address because why do we need to do that? Because we already have a load balancer which will balance the load, right? It will automatically send it to our backend EC2 instance. Why do we need to access the EC2 instance directly? It's basically it's a good security procedure to actually hide our EC2 instance behind our load balancer, and basically there is no need to actually access the EC2 instance directly. So that's why you can use this combination of security groups of the load balancer and your EC2 instance to do this particular thing. Okay, so you have a load balancer security group, you have a EC2 instance security group. The load balancer security group accepts all of the traffic from the world, and your EC2 instance security group basically only accepts the traffic from the load balancers security group. That's what I really mean in this particular scenario, and we are going to see everything in action. Now talking about classic load balancers, basically it supports all of the protocols from layer 4 to layer 7, which are HTTP, HTTPS, TCP, UDP and everything. It has a fixed host name, as you can see. Basically host names are fixed in case of classic load balancers and application load balancers. In network load balancer there is a concept of static IPs we are going to discuss later on, but just understand that classic load balancers are the oldest generation load balancers, and they only support all of the protocols. Okay, application load balancer V2 version 2, right? Application load balancers is layer 7, which is HTTP. Load balancing in multiple HTTP applications across machines, so which are known as target groups. Okay, so which are known as target groups. We are going to discuss what target group or TGs are in detail later on. Then load balancing to multiple applications on the same machine, which is containers. So this is Docker stuff. Don't worry about that. You can easily use anything inside the target group. It can be Dockerized containers, it can be EC2 instances, it can be ASG or whatever you want. Supports HTTP, HTTPS and WebSocket protocols. Supports redirects from HTTP to HTTPS. So which is known as connection termination. We are going to see that later on. Okay, no issues in that. Now routing tables to different target groups. Routing based on path URL, for example /users and /posts or .com and other.example.com. So to be really clear, so you can define rules based on that. It will forward the traffic to a particular target group. For example, you are sending this /user as a path parameter, right? Then you have defined a rule in this particular elastic load balancer or application load balancer which says that, okay, if a /user comes in, please send it to this particular target group, which is for the user's application. Okay, so it will send all the traffic to this particular target group. Now, if /search comes in as a particular path parameter, then you have instructed this particular application load balancer ki bhai, whatever traffic comes in from /search path parameter, please send it to this particular target group. So for example, this is target group 2, this is target group 1. Okay, and basically please send it to target group 2 if this particular /search parameter comes in, and this is known as rules, right? So this is known as rules. So you define rules which will define how the particular elastic load balancer will forward the traffic. Okay, now let us talk about target groups. As I've told you, target groups are just basically the collection of EC2 instances or your targets, right? The targets which the particular ALB will forward the traffic, right? So your target group can consist of EC2 instances, your target group can consist of ECS tasks, which are basically Docker containers. It can also be Lambda functions. I'm going to discuss about Lambda functions later on. It can be a couple of IP addresses also, and it can be another ALB. So one ALB forwards it to another ALB. So that design can be, there will be a public ALB, for example, which accepts all of the traffic from the internet. Then it forwards it to a private ALB, and behind this private ALB there are a couple of EC2 instances, EC2 1, EC2 2, and 3 and 4, something like that. So this is one of the architectures where an ALB is forwarding traffic to another ALB. That can also happen, but it's a little bit complicated, so I'm not going to discuss that later on. So then we are going to talk about health checks, right? Health checks are on the target group level, so it will be based on a particular target group. Okay, so these are all the common principles which you should know about things. Now we saw a particular rule regarding path parameters, right? So basically you can also create rules based on query strings, right? So basically there is a query string coming in. So in the request there is a query string coming in that platform equals to mobile, right? Now if this particular query strings comes in, then basically you forward it to a target group which is EC2 based applications. Okay, and if a query string comes in basically which is platform equals to desktop, then you just forward it to another target group which is an on-premises system. Okay, so basically you have an on-premises system which consists of a couple of web servers. So basically you forward it to there also. That is also possible. So the main point of this particular slide and this particular section is that you can create rules, and based on that rule you can forward the traffic to that particular target group. Okay, so that's what I meant. Now application load balancer, some good to know things, that it has a fixed host name. So for example, you will get a fixed DNS host name. You are going to see that how do you get it. And then the application servers don't see the IP of the client directly. It means that, so this is the client IP where the request is sent, right? So the client IP sends a request to the application load balancer. Here something known as a connection termination happen. It means that the application load balancer actually terminates the connection from your client to your application load balancer. Whatever traffic is coming in, it just terminates the connection. Then what it does is it communicates with your EC2 instance using a private IP address, because from the ALB to your EC2 instance, this communication happens over a private network. And if you don't understand what I'm saying right now, basically it is related to VPCs. So basically it communicates with your EC2 instance over a private network. So what happens? This client IP is lost. So what this EC2 instance seems is only the IP address of this ALB or your application load balancer. The EC2 instance doesn't know the IP of this client because it is communicating with your ALB only, and the ALB does something known as connection termination. If the ALB had sent through the traffic कि बस इस यहाँ से pass करके जाओ to your EC2 instance, then your EC2 instance would have seen the IP address. But in this case, the EC2 instance is not seeing the IP address because connection termination is being happening. Okay, so what will happen? how do you know the client IP in this particular scenario? You use the X-forwarded port or the X-forwarded proto header. Now this header will contain the port and the IP address of your client IP. So if you just analyze your particular X-forwarded proto and X-forwarded port header of the request, then even though your client IP is lost, it will be contained in those headers. Okay, so make sure you understand this concept of connection termination. So your ALB terminates the connection from your client to your ALB, and then it re-establishes a connection to your EC2 instance, which goes over a private network, and it communicates using private IPs. So that's why to know the client IP, you have to go for the X-forwarded for that particular header. Okay, that sounds cool. Let's move on. Okay, so before going to network load balancer, we are going to see a quick demo of how we can work on this particular ALB, and we are going to create a couple of EC2 instances, and we're going to see how they communicate with each other. Okay guys, so we are going to see a particular demo where we are going to create an elastic load balancer and a couple of EC2 instances, and we're going to try to distribute the load between our EC2 instances, right? So let us understand the architecture that we are going to do our lab on, right? What we are going to create in our demo, and what we are going to actually demonstrate. So we are going to start with creating two EC2 instances, right? Two EC2 instances we are going to start, and basically this will be HTTP servers. We are going to install the HTTP servers using user data script. So user data, we are going to use this to particular install this HTTP server, and these two particular EC2 instances will have public IPs, public IP1 and public IP2. So initially what will happen, we will be able to communicate with our web servers using the public IP or the DNS name of our EC2 instances. So EC2 instance 1 and EC2 instance 2, we will be able to communicate with them using our public IP addresses. But the thing is, what we are going to do is we are going to hide these two EC2 instances in front of a ALB, which is an application load balancer. So now what will happen, whenever a user requests something, for example, it will go to the application load balancer first, and this application load balancer will forward the request or distribute the traffic, right, between these two EC2 instances. And these two EC2 instances will be registered as a target group or a TG, because the target groups are necessary for a particular ALB, a particular application load balancer, right? Basically the application load balancer targets should be inside a target group. So this is what we are going to do. Now basically this particular ALB will have a fixed DNS. So we are going to communicate with that fixed DNS only. We are not going to worry about the public IP addresses of these two things, right? We are going to communicate with our ALB only, and our ALB will be responsible for forwarding the traffic to our EC2 instances. So we are going to do this particular architecture right now. So let's go to our AWS console. Okay, so we are in our AWS console, and we understood the architecture, right, what we are going to do. So we are going to go to our EC2 console or EC2 dashboard, and we are going to start by creating two EC2 instances, right? So it is very easy to create. So let's go to launch instances. Sorry, I'm just going to give it a name, my web server 1, and my web server 1. Okay, this is how it is. So I'll keep the number of instances to 2, because basically the same thing, two identical EC2 instances we are going to create with a HTTP server on it. But let's go with Linux 2 and everything, that T2 micro. Let's create a key pair. Let's create and keep a key pair. For example, web server key pair. We are not going to use it, but let's keep it, right? And let's go with the .ppk. Okay, so this is not required, but let's keep it. Now in case of a security group, we are going to create a security group. Okay, and basically I'm going to, for now, let's allow the HTTP traffic from anywhere, right? Then configure storage, the defaults. In the advanced details, I just need to copy one user data script that I have over here, which will install the HTTP server, Apache HTTP server, and it will be having a simple web page, and we discussed all these things in our EC2 lecture. Then I'm just going to click on launch instance. It will take a couple of minutes to launch. Success. Let me go to instances, and will take a couple of time, and I'm going to edit this name to web server 2 so that I can understand this is the web server 1 and this is web server 2. Okay, so both are in pending state. Okay, let's wait for a while. Okay, so one is in running state. So let us select that one running state. So we have a public IP address. Let's copy that and let's go over here. I'm just going to say http:// the site can be reached. I think it still needs a little bit of time. Let's select this instance. Public IP4 address is that http. Okay, now you can see that it is up and running. So it takes a little bit of time to actually install that HTTP server. So yeah, so now you can see that using our public IP address we are able to access this EC2 instance, and this EC2 instance also, if we select the public IP address and just go to another tab, and we will be able to access that particular instance also. Okay, so it will be the that only. So we will be able to access that 230.140. So it takes a little bit of time, but we will be able to access that, right? So using our public IPv4 addresses, we are able to access our EC2 instances. But what we are going to do is, now we are going to create our our ALB, which is the application load balancer. Now let's go to load balancer right here. Okay, now we're just going to go to create load balancer, and over here you see three options. We are going to deal with the application load balancer right now. Don't select the classic load balancer, it's way old and you don't work with old things, right? Just skip that. Create an application load balancer. Okay, so let us give a basic configuration. So the load balancer name will be my LB. Let's name it like that, my ALB. Okay, and it should be internet facing because we need to be public, right? IPv4 address, VPCs, and I'm going to deploy it in all of the availability zones, right? You can deploy that, it is possible. Okay, so just do it, that's it. So just deploy it in a particular region, which is US East, and it will be deployed across 6 availability zones. So you can select whatever availability zones you want. Now for the security groups, let's go with the default one, default SG. Okay, so let us go with the default one. I don't have any other security group, so let us keep separate the launch wizard one, because launch wizard one is for that particular EC2 instances. So let us keep a separate security group for our our load balancer. Now for listeners, for now I'm just going to keep a simple listener of HTTP at port number 80, and it says that okay, forward it to a target group. For now we don't have a target group, so we're just going to create a target group. Okay, in this particular target group you can see there are a couple of things that you can keep in your target group. So we want instances to be, that 2 EC2 instances that we created, we want those to be in our target group. So we're going to select instances over here. Okay, VPC, protocol version HTTP1, health checks, HTTP, let it be, and click on next. Okay, so target group name, let's name it as my ALB TG. Okay, so my application load balancer target group. Next. So now if you see, there are 2 particular instances that I can register as targets in my target group. So I'm just going to select both of them and include as pending below. Okay, so it is done. Now let us create the target group. Okay, so this particular target group has been created. Okay, now what I need to do is go back to my load balancer, just refresh this particular list, and if I just go here, I can see my ALB target group. now if you see, if you want to integrate with global accelerator, don't worry about that. We're going to see what global accelerator is later on. Okay, now I think we are done. We are basically done. So we are going to just click on create load balancer. Okay, so let us go and view the load balancer. So it is in provisioning state. It will take a little bit of time, so I'm going to pause the video right now, and then we are going to, after it is done provisioning, we are going to continue from there. Okay. Hi guys, so you can see that my application load balancer is in active state right now. So if I just click on this particular application load balancer, you can see all the details regarding my application load balancer, like the availability zones it's available in, and then the fixed DNS name, right? Here there are the listeners, like any traffic that comes in at port 80 HTTP traffic, it will just forward it to a target group which consists of 2 EC2 instances, which is my ALB target group. So it's a simple rule. Now going to security. If you see the security group of this particular application load balancer, and if I click on edit inbound rules, so you can see it allows HTTP traffic from anywhere. Okay, so basically if I just try to communicate with the application load balancer using HTTP traffic, I'll be able to communicate with it, right? That's what this inbound rule says. Okay, so it seems good. So these are the security groups. It can also see some monitoring things, like what are the requests, how many requests are coming and everything. You can see all these things. You can go to integrations and integrate with other services like WAF, global accelerator, or any kind of other services. Okay, so yeah, now let us copy this DNS name, right? And let us go over here and let's say HTTP // then our DNS name, right? Our application load balancer's DNS name. Now we can see that it is forwarding the traffic to our EC2 instances. Now if I keep on reloading, you'll see that this particular IP address changes. It means that it is distributing the traffic across our EC2 instances, right? So our application load balancer is working. So the diagram that we saw, so basically our application load balancer is forwarding the traffic, some traffic to this EC2 instance, some traffic to this EC2 instance, right? So our particular architecture is working. Now if I go back to our EC2 instances, right, our instances, and if I just select an instance, for example this instance, and if I just select its public IPv4 address and just go to a new tab, do this thing, then you can see that we are still able to access our EC2 instance directly, which we don't want, right? Which you don't want. We are able to access our EC2 instances through our application load balancer, which is good, but we are also able to access our EC2 instance directly through the public IP, which we don't want. So let us go to our diagram and let us do some other stuff. Now you see this public IP over here, we are going to not do this particular thing. Okay, so this thing will not remain right now. So what we are going to do, so this is in a target group, right? So this is the target group, and this is associated with a security group SG, which is basically launch wizard 1. Now what we are going to do, basically we are going to create a rule, or remove the rule which says HTTP from anywhere. Basically we are going to invalidate that rule, and we are going to allow HTTP from the target group of TG of ALB. We're going to do that. So we're going to remove HTTP from anywhere. We're going to allow HTTP from the target group of the ALB. Now what will happen? Only HTTP traffic coming from the ALB will reach our EC2 instances. If outside user directly tries to access our EC2 instance, then it will not be able to access our EC2 instance. So that is how we are going to change our architecture a little bit. Now let us go back. Let us go to security groups. Here we have two security groups. So I think our launch wizard 1 is our security group for our EC2 instances. We're going to just select that. Over here we're going to go to our inbound rules and edit inbound. So in this particular launch wizard 1 security group, you can see there is a rule for HTTP. So we are going to keep that SSH rule. Let's keep that SSH rule for now. But in this particular HTTP rule, basically it is allowing HTTP from anywhere, right? And according to our diagram, we are going to only allow HTTP traffic from our load balancer. So we're going to allow HTTP traffic from our load balancer's security group. So we're going to delete this rule, and then we're going to add a rule which says HTTP, okay, HTTP traffic from the source is from custom, and we are going to select the security group of our load balancer. So which is this default SG, right? This is the particular security group of our load balancer. Now I think it is done. Now let's save the rules. Okay, so our security group rules are saved. Now if I go back to here, then if I try to access our EC2 instances directly from our load balancer, it works, right? It is distributing the traffic and we are able to see the traffic, HTTP traffic is going to the EC2 instances. Now if I go back to our instances and if I just select one of the web server 2 for example, and if I select this public IP address and then we go HTTP, now you can see that here you can see the connection refused error, right? So it is not allowing, you know, public access, public HTTP access directly to our EC2 instance, because in our security group of our EC2 instances we have denied access HTTP from anywhere. We have only said that okay, please only accept HTTP from our application load balancer. That's why we are able to access this thing using our load balancer. So this is one of the things that you should keep in mind. Okay, cool stuff, right? Cool stuff. Now if I go back to here, there is also one more step you can take while creating a EC2 instances. You can also say that don't create any public IPv4 address. You can also do that. You can only create private IPv4 address, okay, which and you will associate it with a subnet. We are going to see later on how you can create subnet, private subnets and public subnets, and you can just take one other step and just remove the public IPv4 address directly. In that sense, you do not pay for that public IPv4 address or anything. You are also saving on money, and also you are making it more secure by keeping your web servers private. Okay, so this is how you can work with application load balancer and your EC2 instances, right? Now before moving any more further, I'm going to terminate my EC2 instances because we are not going to use it right now anymore. So I'm just going to go to instance state and terminate it. Okay, because we are going to talk about auto scaling groups, and for that I don't require these two EC2 instances anymore. Okay, now let us move forward to the next topic. Now let's talk about network load balancers. Okay, just a minute. All right, network load balancers. Now basically, as I've told you, right, network load balancers are layer 4 load balancers. So you can forward TCP and UDP traffic to your EC2 instance, your instances. You can handle millions of requests. This is the key term over here, millions of requests. So whenever in the exam you see anything related to millions of requests and load balancing stuff, please go for network load balancer. So NLB has one static IP. This is also one of the key terms. It is associated with one static IP. Only network load balancers can be associated with a static IP. Now don't confuse between fixed DNS name and static IPs. Okay, fixed DNS name means that your DNS names will be fixed, but your public IP address may change. But in case of a network load balancer, you are only associated with only one static IP or a fixed IP, and it supports assigning elastic IP, which is not supported in application load balancers. Okay, it's only supported in network load balancers. So it is used for extreme performance. This is also one of the key terms. So always remember the key terms before going into the exam. And it is not included in the AWS free tier. So sorry guys, I will not be able to show this particular demo regarding network load balancers. But it kind of the integrations are same like application load balancers. Okay, so you don't have to worry about that. Okay, now let's move forward. Network load balancers, TCP layer 4 based traffic. Basically, what will happen? Your request comes in, right? It is TCP plus rules, whatever you have, and then it just forwards it to a traffic group, target group 1, target group 2, right? Basically, it's the same kind of thing as application load balancers. So network load balancers also work with target groups. So sorry, let me just remove all this ink from here, otherwise it will just stay there. Okay, network load balancer, target groups. So your target groups can be EC2 instances that we saw. It can be IP addresses, can be another application load balancer, and health check supports TCP, HTTP and HTTPS protocols. Okay, so here you can see it is a target group of EC2 instances. Now the load balancer, network load balancer, is associated with a target group of a particular EC2 instance and a on-premise web server, and then here the network load balancer is associated with another application load balancer. So same target groups that we used with ALB, same kind of target groups can be used with a network load balancers also. Now moving forward to gateway load balancer. Now this is kind of a new load balancer, and basically it is kind of related to security. Now let us understand that. Deploy, scale and manage a fleet of third party network appliances in AWS, right? Network appliances. So whatever you deploy behind a network load balancer, it will be some kind of a network appliance. Now what kind of appliance? It can be firewalls, it can be intrusion detection and deep packet inspection. So basically you filter the packets before it goes into your application. For example, here the users send the traffic, it comes into your gateway load balancer, filtering happens over here, or inspection, whatever you're going to say, and then it is sent back to your application over here. Operates at layer 3. This is also a very important key point. अगर कोई network layer का अगर question आता है load balancer, please go with gateway load balancer. Combines the following functions: transparent network gateway, single entry exit for all traffic. So it kind of acts like a watchman or a gatekeeper. Okay, so I kind of reminded of Hagrid. Sorry. Now load balancers distribute traffic to your virtual appliances, right, and uses the Geneve protocol on port 6081. So whenever you see this particular thing also in the exam, go for the gateway load balancer. Okay. Gateway load balancer target groups can be EC2 instances, can be IP addresses. So you cannot access. Here it is a little bit of different. The target groups can only EC2 instances, can be only IP addresses. You cannot go with ALBs or NLBs as target groups. Okay, or you cannot go for other stuff. Okay, so it can be EC2 instances or IP addresses. So remember that. Now let us talk about sticky sessions or session affinity. So it is possible to implement stickiness so that the same client is always redirected to the same instance behind a load balancer. To put it in simple terms, basically in this particular diagram that you see, right, so basically whenever a request comes in, right, so in this particular thing what happens is that the ALB redirects to any one of these EC2 instances. It doesn't care that okay, I last time I redirected the request to this EC2 instance, so I will be redirecting to this EC2 instance only for the same user, right? It can redirect it to a different EC2 instance, or if there are 4 EC2 instances, it can redirect to another EC2 instance. So it depends on the ALB, right? You don't have control over it. So using sticky sessions, what happens is that that particular client is redirected to that particular EC2 instance or the target group only. Okay, so you can see in this particular example, client 1, it had communicated with this EC2 instance, so all subsequent requests are sent to that particular EC2 instance only. Client 2, over here, it communicated with this EC2 instance, so all that requests are coming into this particular EC2 instance. Okay, now client 3, okay, it started communicating with this particular EC2 instance. Now further requests are going to come into this particular EC2 instance. So that is what we mean by sticky sessions or session affinity. It kind of maintains a session. It can maintain a session with that particular EC2 instance for that particular client. Okay. Sometimes it is necessary, so you can just think about it in that way. Now let us talk about the cookie names. Now basically whenever you are going to establish sessions, you are going to store some data in cookies, right? So basically you need to associate it with cookies. And if you are going to talk about cookies, there are application based cookies and duration based cookies. Now in application based cookies, there is something you can generate a custom cookie. It is generated by the target, which is basically your EC2 instance, can include any custom attributes required by the application, for example username, right? Or if you store the password, which is not good practice to store the password, but you can store some custom attributes like username, password or some other kind of data. Cookie name must be specified individually for each target group. You have to specify the particular cookie name and the data that it's going to store. Okay. Now don't use AWS ELB, AWS ELB app or AWS ELB TG, right, reserved for use by the ELB only. So you cannot use these cookie names, okay, because they are reserved by the particular application load balancer or the elastic load balancer itself. So you cannot use that particular cookie names. Okay. Now there is some application cookies which is generated by the load balancer automatically. The cookie name is basically AWS ELB app. If you are going to use it with AWS ELB, basically it is going to be named like this. Then we have duration based cookies. So it is generated by the load balancer and the cookie name is AWS ELB or ALB or AWS ELB for CLB, which is classic load balancer. So duration based cookies, basically for a specific duration it stores the data. Okay. All right, so let us move forward. Now before going to another topic, let us talk about, see a demo on particular sticky sessions, right? We're going to see how you can configure sticky sessions for this particular demo. All right, so I kind of terminated my EC2 instances, so I need to recreate it. गलती से मैंने EC2 instances को terminate कर दिया. So let me just pause the video and let me recreate my EC2 instances. Let me associate with my ALB and then let's continue with our particular lecture. Hi guys, so I have recreated my EC2 instances. As you can see, web server 1 and web server 2, and I have registered it as targets in my target group. So if I go back to my application load balancer, if I just keep on reloading this, you can see I am being redirected to different EC2 instances as per the thing. But the thing is, if I visit this particular EC2 instance, which is having 115 as the last private IP address, like 172.31.10.115 as the private IP address, I should visit that same EC2 instance to maintain a session, right? Kind of maintain a session affinity. Now that's why what we can do, we can use sticky sessions in this case. And how do we enable sticky sessions, right? So let me go back to my target groups over here, and let me click on this target group and let me go to attributes, right? And here the stickiness is off, as you can see. Now let me click on edit over here, and if I just scroll down here, if I just click on enable stickiness, okay, I can create my own custom application based cookie. I can name the application cookie, right, my custom cookie or something like that. Basically I don't want to do that. I'm just going to use the load balancer generated cookie which will be basically named as AWS ELB, something like that we just saw in the slides. And for how many days you want to maintain that particular stickiness. You can also select minutes or hours. You can select for 1 hour I want to maintain the session with our target group, with that particular EC2 instance, for example, right? After 1 hour, basically that cookie will expire and the normal functioning of the load balancer will be reverted, so it can redirect your request to any of the EC2 instances, right? I'm going to save the changes as of now. Okay, so I have enabled stickiness. Now let me just go back to my EC2 instance and let me just reload a couple of times. So here once, okay, reload. It will take a little bit of time, I think. Okay, now you can see that now if I keep on reloading, I am only redirected to this particular 172.31.12.84, right? If I just keep on reloading, I just see that, okay, I'm just only redirected to this particular EC2 instance and not the other one. So this is how the session is maintained. Now basically a cookie is generated, and in that cookie the session is maintained, right? And this is known as session affinity. Now you can see that the session is maintained in this particular case. Okay, now let me go back to our slides and let us continue. So we talked about session affinity and everything, right? Now let us talk about cross zone load balancing. Now what is particularly cross zone load balancing? If you see this particular diagram, what happens without cross zone load balancing? Requests are distributed, right? Distributed in the instances of the node of the elastic load balancer, right? So what is happening over here? So we have two availability zones, availability zone 1 and availability zone 2, and basically here the requests are divided like this. So 50% comes in, 25% is sent to a particular EC2 instance, and another 25% is sent to this particular EC2 instance. Now here with this particular load balancer, the 8 EC2 instances are actually associated with this particular load balancer, right? So now each particular load balancer is receiving 6.25% of the requests, right? So for each each availability zone, the amount of requests, right, that a particular EC2 instance handles is different. For this particular EC2 instance, for this particular availability zone, as there are only 2 instances, each of those instances handling 25% of the traffic. For this particular availability zone, as there are 8 EC2 instances, so each EC2 instance is handling 6.25% of the traffic. So they are different. So they are not actually uniform across the availability zones. Now what happens if you enable cross zone load balancing? When you enable cross zone load balancing, what happens is that each load balancer instance distributes evenly across all registered instances. So irrespective of how many availability zones your EC2 instances are, all of your EC2 instance will get the same amount of traffic. Like in this case, all the EC2 instances are getting 10% of the traffic. This is what cross zone load balancing is. Okay. Now let's talk about some other features of cross zone load balancing. Okay. One of the features in application load balancer is that it is enabled by default. So basically when you create an application load balancer, cross zone load balancing is enabled by default and can be disabled at the target group level. Okay, so if you go to attributes of target groups, you can disable cross zone load balancing. There are no charges for inter-AZ data. Okay, so you do not pay for any charges if the data travels from one availability zone to another availability zone. Now talking about network load balancer and gateway load balancer, these are disabled by default. Okay, so if you enable cross zone load balancing, you are going to pay charges for that particular inter-AZ data if they are enabled. So you need to remember this key point. So charges are incurred if you enable it in a network load balancer. No charges if you go for an application load balancer, right? It is same for the gateway load balancer also. So charges will be incurred if you enable cross zone load balancing in gateway load balancer also. Now for classic load balancer, if you create a classic load balancer, it is disabled by default and there are no charges if it is enabled. Okay, simple as that. Now let us move on. Now let's move on to the next topic, which is known as SSL and TLS. Okay, we are going to see this particular thing, SSL or TLS. So an SSL certificate allows traffic between your clients and your load balancer. It will be encrypted in transit, which is known as in-flight encryption. Basically we are talking about if you are going to send traffic in HTTPS, so that is encryption in transit, right? And you need a certificate for that. So basically SSL refers to secure sockets layer used to encrypt connections. TLS refers to transport layer security, which is a newer version. Okay, nowadays TLS certificate are mainly used, but people still refer to it as SSL. Okay, so every time when I'm going to talk about in transit encryption, I'm going to say it as SSL. Okay, so basically public SSL certificates are issued by the certificate authorities, CA. So like Comodo, Cinematic, GoDaddy, GlobalSign, DigiCert, a lot of authorities are there which assign public SSL certificates. And SSL certificates are associated with an expiration date and it must be renewed. Make sure that you know what expiration date you are setting, and basically it can be renewed. So make sure you are renewing your SSL certificate before using it. Okay. Now what we are going to talk about load balancer SSL certificates. So load balancer uses an X.509 certificate, which is an SSL or TLS server certificate. So you can manage a certificate using ACM, which is AWS Certificate Manager. So you can upload your certificate into ACM and you can directly integrate ACM with your load balancer. It will automatically pull that particular certificate from the ACM, which is AWS Certificate Manager. You can upload your own certificates alternatively. Okay, you can also create your own certificates and you can use it alternatively. Now HTTPS listener, you must specify a default certificate. So till now we are talking about HTTP listeners, right? So we created a listener at port 80, right? So we didn't need a certificate, right? Because it is normal HTTP traffic. But if you are going to create an HTTPS listener, you must specify a default certificate, because without a certificate HTTPS doesn't work. Okay, you can add an optional list of certificates to support multiple domains. For example, your EC2 instance, your load balance is actually associated with multiple domains like example.com and ex.com, 2 domains. So for each domain you need a certificate. So make sure you have an optional list of certificates for multiple domains. Okay, clients can use SNI, which is server name identification, to specify the host name they reach. ability to specify a security policy to support older versions of SSL TLS. So these are all supported by the load balancer. Now what happens over here? So this is here HTTPS termination happens, right? What happens? Basically users send HTTPS encrypted traffic to your load balancer, right? And then what happens? Your load balancer terminates that HTTP connection and then establishes a secure HTTP connection over the private network to your EC2 instance. Same thing that we discussed previously. Here also the connection termination happens, but in this case it is the HTTPS connection termination or TLS or SSL termination, right? Because it is a secure traffic that is coming in, that is HTTPS traffic. So it terminates the traffic at the load balancer level, then it establishes a HTTP connection with your EC2 instance, right? And then it is communicated over the private network. Now over the private network it is fine if you communicate over HTTP because it is secure, because it is isolated from the outside world. So this is what connection termination means, and this is what HTTPS or TLS termination means. Okay, so you need to understand this particular concept thoroughly. Now what is meant by server name indication or SNIs? Okay, now SNI solves the problem of loading multiple SSL certificates into one web server. So basically you have multiple domains. So here you have an SSL certificate for domain1.example.com, like I said before. Here you have another one for mycorp.com. So it's a new protocol and requires the client so to indicate the hostname of the target server in the initial SSL handshake. So in the initial SSL handshake, it identifies, okay, this is coming from this particular domain, so I need to load this particular SSL certificate. After this particular SSL certificate has been loaded, based on the HTTPS rules that you have defined, it will redirect that particular traffic to that particular target group. So for example, domain1.example.com, this particular domain is identified by SNI, right? Now that particular SSL certificate will be loaded into ALB. In the HTTPS rules, you have said that, okay, for this particular domain, redirect to this particular target group, right? After that, it will be redirected to this particular target group. Okay, this is how it happens. So now SNI only works for ALB and NLB, newer generation and CloudFront. It doesn't work for CLB, which is classic load balancer के लिए काम नहीं करता है. So basically, this is the rules regarding server name indication or SNI. Okay, elastic load balancer SSL certificates. Classic load balancer, you have already talked about that only supports one SSL certificate. It cannot support multiple SSL certificates, right? Must use multiple CLB for multiple host names. That's why this is disregarded to be used, because it has a lot of problems. Now talking about application load balancers, which is a V2, right? It supports multiple listeners with multiple SSL certificates. Okay, it uses server name indication SNI to make it work, because classic load balancer doesn't support SNIs or server name indication, so it doesn't work like that. But application load balancer supports SNI. So using only one ALB, you can handle multiple domains, right? Now network load balancer supports multiple listeners with multiple SSL certificates and uses SNI. So if you have multiple domains with multiple certificates, please go with application load balancer or network load balancer based on your requirements. Okay, so let us talk about connection draining. So feature naming, connection draining for CLB and deregistration delay. So basically the same thing that you talk is connection draining, the same thing is deregistration delay for ALB and NLB. So for CLB we say it as connection draining, for ALB and NLB we say it as deregistration delay. Now time to complete in-flight requests while the instance is deregistering for unhealthy instance. For example, your ALB instance is associated with 3 instances, right? Number 1 over here, number 2 over here, and number 3 over here, right? Now what is happening, this particular EC2 instance is unhealthy. Okay, now what will happen if there is some requests which are already done to this particular EC2 instance, right? Some in-flight requests are there which are already sent to this EC2 instance. Then before termination of this EC2 instance, it will wait for, the ELB will wait for the completion of that particular requests. after the requests are being completed, this particular EC2 instance will be terminated because it has stated to be unhealthy, right? That is why the particular connection draining period is particular specified, so that for how much time that particular unhealthy instance can be there to accept the requests, to complete the requests. So basically stop sending new requests to the EC2 instance which is deregistering, and it can be from 1 to 3600 seconds. Default is 300 seconds, can be disabled, set to a low value if your requests are short. Okay, so basically it will just wait for the existing connections or requests to complete, and after that particular thing is completed, it will be marked as unhealthy and then it will be terminated. That is what connection draining means, or it is also known as deregistration delay. In the exam you can either see this word or this word, both the things just mean the same thing. Okay, all right, so that is all about, guys, elastic load balancing, right? And we're going to start with elastic load balancing and auto scaling groups later on. Okay.